Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 2 for October-November 2023, and the code is 9709/62. So let's move on to question number 1. Question number 1a, a random variable x has the distribution which is Poisson distributed with mean 25. Use the normal approximation to the normal distribution to find the probability that x is greater than 30. Okay, so from here we know that this is the lambda, so lambda equals to 25, which is greater than 15. Therefore, we need to use the normal approximation. Okay, so now according to the normal approximation, we need to know the mean and also standard deviation. So since your x is Poisson distributed with lambda 25, that means this lambda is mean is also variance, okay, which is 25 for the normal approximation. That means this is going to be W normally distributed with mean 25 and variance 25. Alright, so from here, I will say that you need to calculate Px greater than 30. Now, you have to be careful with this because your Poisson is discrete. Right, it's discrete random variable. I mean the x is discrete random variable because it is Poisson distributed. And then the normal is continuous distributed. Right, that means the normal is a continuous distribution. So from discrete you change to normal. That means you need to carry out the continuity correction. Alright, so now from here I will just draw a line to show that this is x greater than 30. I will label 30, then followed by 31, then 32. So now my x will be 31, 32, and so on. So now when we apply the continuity correction, we have to consider whether we plus or minus 0.5 from 30. That means either you are getting 29.5 or 30.5. But since this is greater than, that means we have to consider the region towards the right side. So obviously from this number line, we need to choose 30.5 to include the two ticks, the green color. Okay, which means I have to solve PW greater than 30.5. Alright, so now when it is normally distributed with mean, mu, variance, sigma squared, we need to standardize. So this standardized random variable z equals to x minus mu over sigma. Alright, so now I'm going to standardize it. It will be z greater than 30.5 minus my mean is 25 and variance is 25 as well. So now I have to divide by 25, which is my standard deviation. Then from here, you will be getting Pz greater than 1.1. So when greater than 1.1, now we need to sketch a graph and get the region. So the middle value is 0 because it's symmetrical at 0. 1.1 is on the right side. When greater than 1.1, the region is towards right side. But when you refer to the normal graph, the region is always towards left side. So now I have to use the total region, which is 1, minus the region which is towards the left side, which is also Pz less than 1.1. Okay, then from here, you can just read the probability from the table, and you will be getting 0.8643. So when you simplify this, this is going to be 0.1357. And now when we round up to 3 significant figures, that is going to be 0.136. So this is the solution for 1A. Okay, so now let's move on to the next part, which is the B. A random variable y has a distribution, binomial distributed, with n hundred, and probability of success is p, whereby the p is less than whereby the p is less than 0.05. Use a Poisson approximation to the binomial distribution to write down an expression in terms of p for probability of y less than 3. Okay, so from here we know that since your n is 100, because here is n, this is p, then your p is less than 0.05. Then from here, when you calculate the np, it's basically less than 100 times 0.05. That means this np is going to be less than 5. Okay, so now because of np less than 5 and your n is greater than 50, therefore instead of binomial distributed, you approximate to Poisson. Okay, so now your mu equals to np, the mu or lambda in the Poisson. Alright, you can write lambda or you write mu. That will be np. That means it's going to be 100p. Okay, so from here I will write y. Y is binomial distributed with with n 100 and the probability of success is p. Now it will be approximate to Poisson distributed with lambda equals to 100p. Okay, so because the question says you need to leave your answer in terms of p. So therefore my lambda here or my mu here is going to be 100p. So now probability of y less than 3. Okay, now for this question, the continuity correction is not needed because binomial is discrete. It's discrete distribution, and then this Poisson is also discrete. Okay, so both are discrete, therefore we do not need to carry out the continuity correction. It is different from the A. Then now what to do is just solve as usual. When your y is less than 3 means that basically okay, let's say I change to W because I have approximated to Poisson distribution, so it will be W less than 3. So when W less than 3 means that W is equal to 0 or 1 or 2. Okay, so for the Poisson distribution, so if let's say your x is Poisson distributed with mean lambda or mu, your px equals to x is going to be e minus lambda x over x factorial. Okay, you can write as mu or lambda. Then from here, I will be getting e minus 100p because my 100p is my lambda or mu. So it will be e minus 100p. Then, because I know that the e minus lambda is a constant, that's why I factorize it, and the rest I will just change accordingly. Therefore, it will be minus 100p to the power 0 over 0 factorial plus my lambda is 100p. Okay, so there is no negative over here, so here is going to be 100p degree 1 over 1 factorial plus 100p degree 2, whereby the x is 2, then over 2 factorial. Then from here you will be getting e negative 100p. Now 100 to the power of 0 is 1. Okay, this is 1. Here is 1. 0 factorial is also 1. Therefore, the first term is 1. Then plus 1 factorial is 1 for the second term. So I will just write 100p. Then the next term, when you do expansion, 100 squared divided by 2 factorial is going to be 5000. Then squared of the p, it will be p squared. So this will be the probability of y less than 3 in terms of p. Alright, so now let's move on to question number 2. The length in minutes of mathematics lectures at a certain college, this is the length, right, has mean, mu, and standard deviation 8.3. A, the total length of a random sample of 85 lectures was 4,590 minutes. Calculate a 95% confidence interval for mu. So we know that 95% confidence interval for mu, the formula is x bar plus minus z sigma over square root n. So it means that first step is to get the x bar. Now, since the total is 4590 for 85 lectures, that means x bar is going to be summation x over n, which is 4590 divided by 85. Okay, then from here you will be getting 54. That is our x bar. So here I found 54 plus minus. Now this z value depends on 95%. So now draw the graph. Okay, normal graph. 95% means that in between is 95. Or I would say that this is 95%, which is also 0.95. So when the middle is 0.95, the remaining regions here, okay, it will be 1 minus 0.95, which is 0.05, and that 0.05 is shared by two parts, which means this is going to be 0.05 divided by 2. Then you'll be getting 0.025. Okay, then from here, I know that my total region towards left side, I mean from this line to the left side is going to be 0.95. Sorry, 0.975. When you add up the orange region and also the green value, all right, this is 0.975. Okay, then from the table you will be getting this value as 1.96. Okay, this is also 1.96, but it is negative. Or here is going to be 1.96. Now this sigma is given, which is 8.3. So 8.3 over square root, our n is 85. Right, then from here, when you calculate the negative value, using the negative value, you will be getting 52.2, which is correct to 3 significant figures, whereby when you count using the plus, you will be getting 55.8. So that's the confidence interval for mu. Okay, now the length in minutes of history lectures has mean m and standard deviation s. B, using a random sample of 100 history lectures, so this is the n, a 95% confidence interval for m. So this m is the mean, right, which is the mu just now, was found to have width of 2.8 minutes. Find the value of s. So from here, I will write your y is normally distributed, mean m, variance s squared. So then the n is 100. Okay, that means this is going to be over 100. Alright, so what to do here is we need to find the width of the confidence interval. So basically it is similar to previous, right? So from here, the width is basically double of this part, because we know that the formula is x bar or y bar plus minus z sigma over square root n, okay, or s over square root n in this case, right? So it means that this is y bar, here is z s over square root n, and this is the width, I mean the width from the y bar will be z over s over square root n. So now the width for the confidence interval, this will be the confidence interval, it will be double of z s over square root n in this question. Okay, so then just replace the values. So I will be getting width equals to 2.8. So 2 times z s over square root n will be 2.8. And again, this is 95%. So for 95%, you can refer back to the previous value, okay, which is here. See here, 95%, the z value is basically 1.96. So now I will just replace the z value by 1.96. Then the s remains. Then the n is 100. Right, so square root 100 equals to 2.8. Then from here, the left hand side, you will be getting 0.392s. Then right hand side remains as 2.8. Then now your S is going to be 2.8 divided by 0.392. Then you will be getting 7.14. So that's the solution of this part B. Okay, so done for this question. Now question number 3. A researcher read a magazine article which stated that boys aged 1 to 3 prefer green to orange. It claimed that when offered a green cube and an orange cube to play with, a boy is more likely to choose a green one. Now, the researcher disagrees with this claim. She believes that boys of this age are equally likely to choose either color. In order to test her belief, the researcher carried out a hypothesis test at 5% significant level. She offered a green cube and an orange cube to each of 10 randomly chosen boys, aged 1 to 3, and recorded the number, which is X, of boys who chose the green cube. Now, out of 10 boys, 8 boys chose the green cube. Now, A, first part, assuming that the researchers believe that either color cube is equally likely to be chosen, is valid. A student correctly calculates the probability of X equals to 8, which is 0.0439, correct to 3 significant figures. He says that because of this value is less than 0.05, so the null hypothesis should be rejected. Now, explain why this statement is incorrect. Okay, basically, our H naught is P equals to 0.5 because equally likely to be chosen. Right? Now, it's mentioned that the boys is more likely to choose a green one. So now your X is how many boys choose the green cube. That means now it believes that the P is greater than 0.5. Therefore, it's more likely higher percentage to choose a green cube. Okay, now if let's say you need to reject the H naught or the null hypothesis, we should calculate or count. Okay, we should count the probability that X at least 8, because the at least 8 depends on the H1. If your H1 is greater than 0.5, then it will be at least 8. If your P is less than 0.5 in your H1, it depends on your H1. So if it is greater than 0.5, it's greater sign, therefore here greater and equals to. But if let's say it is less, okay, then here should be less than equals to. Okay, and not just to count Px equals to 8. So this means the mistake is over here. Okay, so the explanation is we should count this probability and not Px equals to 8 due to your H1. Alright, so done for first part. Now part 2. Carry out the test on researchers' claim that either color cube is equally likely to be chosen. So for this case, equally likely means that the P is 0.5 for the H1, for the H0, and then the H1 is P greater than 0.5. Alright. So now your alpha value, because it's mentioned in the question, the significant level is 5%. So the alpha will be 0.05. Now, we should write down the rejection criteria, which is reject H0 if probability of X at least 8 is less than the alpha value. Okay, and now we know that it is binomial distributed. Your X is the number of boys prefer the green cube. So there are 10 boys in the question, and the probability is 0.5 when the H0 is true. So now we need to calculate Px greater and equals to 8. So greater or equal to 8 means that it will be 8, 9, and 10 for the x values. Right? So for binomial distribution, so if let's say your x is binomial distributed with mean with n and p, then the probability is basically ncx, px, qn minus x. Okay, so now from here, our p, this is the p. So p is 0.5, therefore p is 0.5. Therefore the q is also 0.5 because that is 1 minus p. Okay, so I do step by step. It is 1 minus p, which is also 0.5. Now, when you apply this formula, it will be 10C8. P is 0.5, Q is also 0.5. Okay, then here it should be always total of 10. So I can just write 0.5 to the power of 10 because P is same as Q. Plus, then Px equals to 9 means that 10C9. Then again 0.5 to the power of 10 plus all successors 0.5 to the power of 10. Okay, then from here you need to count one by one. So now I calculate one by one and give more decimal places because this is the working. So the first value is going to be 0.043945, and then the second value is 0.0097656, and then the last value is going to be 0.000097656. So when you add up these three values, you will be getting 0.0547. And then we know that this is greater than 0.05. Now, according to this rejection criteria, so if it is greater than 0.05, we cannot reject H0, right? Because it should be less than 0.05. So now here I will just write since Px greater or equals to 8 is greater than 0.05, so do not reject H0. Okay, so when we do not reject H0, what is the conclusion? So we want to check whether the claim is equally likely or not. So if do not reject H0, that means it will be equally likely. Okay, or probably you can just write there is not enough evidence, there is insufficient evidence to conclude that the boys will be more likely to choose the green cube. Insufficient evidence to conclude that the boys are more likely to choose green cube. Than the orange cubes. Okay, so that's the conclusion for this question. Alright, now B. Another researcher claims that a type 1 error was made in carrying out the test. Explain why this cannot be true. Okay, so now we need to calculate, or we need to refer to the probability of getting type 1 error. So type 1 error says you need to reject the H0. Okay, given that H0 is true. That is the definition of type 1 error. So from here, we know that our conclusion is do not reject H0. So when do not reject H0, we are not able to calculate probability of type 1 error because type 1 error means we have to reject H0. Alright, so the reason is, the conclusion is H0 was not rejected. Okay, so that means we cannot calculate the type 1 error. Alright, so that's the reason for this question. Okay, now a similar test at the 5% significant level was carried out later using 10 other randomly chosen boys aged 1 to 3. Calculate the probability of a type 1 error. Okay, so from here, P type 1 error, we have defined it just now, which is reject H0 given that H0 is true. Okay, so now from here, you refer back to the previous calculation. Now, when you need to reject H0, okay, make sure it is less than, the probability is less than 0.05. But then if it is greater, I mean probability of X at least 8, I'm getting this value. So to make sure that it is less than 0.05, right, based on these three values, if I just consider summation of Px equals to 9 and 8, these two values, the total is basically less than 0.05. So which means I will have to reject H0 when the X will be 9 and 10. Okay, so now from here, I know that I'm going to calculate Px at least 9. Alright, because Px at least 8 is greater than 0.05, then Px at least 9 is going to be less than 0.05. Then this will cause you to reject H0. Okay, so now this calculation we already done in previous part. So probably you can just copy down the working over here. Right, this will be the working, and then direct get the final answer. Then from here, I will just write, it will be 10c9 0.5 to the power of 10, then plus 0.5 to the power of 10. Okay, then from here, you can just get the total of the values from previous part. You will be getting 0.0107, and this is going to be less than 0.05. So this will be the probability of making the type 1 error. Okay, so let's move on to the next question. Question number 4. The height h in meters of mature trees of a certain variety is normally distributed with standard deviation 0.67. In order to test whether the population mean of h is greater than 4.23, the heights of a random sample of 200 trees are measured. A. Writes down suitable null and alternative hypothesis for the test. Okay, so from here I will just write H0, which is my null hypothesis. The mean population mean, I would say population mean of H is greater than 4.23. That is your H1. Okay, so mu is greater than 4.23. So since mu is greater than 4.23, that means your H0 or the null hypothesis is going to be mu equals to 4.23. So that's the solution of 4A. Now the sample mean height h bar of 200 trees is found and the test is carried out. Okay, 200 trees. The result of the test is to reject the H0 at 5% significant level, means alpha is 0.05. Now find the sets of possible values of h bar. Okay, so now you have to write down like this. So H is normally distributed with mean mu, then variance is 0.67 squared, because that's the standard deviation, right? So here I will write 0.67 squared. And then it's mentioned that you are going to reject the H0 at 5%. So now I will just sketch a graph. Okay, sketch a graph. This is 0. Now, by looking at the H1, okay, by looking at the H1, which is greater than, so which means this is upper tail test. So which means now 0.5, okay, 5%, 0.05. So here I will write alpha is 0.05. So it's going to be the upper tail. This is your 0.05. Okay, so then from here I know that to get the value from the table, you have to read 0.95. So that the total properties will be 1, or total area of the region will be 1. Then here is going to be 1.645. Okay, so now my rejection criteria should be reject H0 if the Z is greater than 1.645 according to the graph. Then from here, my Z value is going to be H bar minus mu over sigma over square root n. Okay, so now my Z is going to be more than 1.645. That means, alright, so H bar minus mu over sigma over square root n is greater than 1.645 because my Z is greater than 1.645. Then now, the mu is not given. Let me check. The mu have we found? Okay, the mu is given at the H0, right? So we refer to the H0, so which is 4.23. So now I will write H bar minus 4.23 over standard deviation. Standard deviation is given as well. This is standard deviation, sigma, which is 0.67. So here I will write 0.67, okay, over square root. The n is 200, sorry. N is 200. This is your n. So here is 200. That is greater than 1.645. Alright, so from here to get the H, simple. So just move this whole term to the right side and then followed by moving the negative 4.23 to the other side, which means now my H bar is greater than 1.645 multiplied with 0.67, then divided by square root of 200, then followed by moving the 4.23, the negative 4.23. So I will get plus 4.23. Okay, so from here your H bar is going to be greater than 4.31, which is 3 significant figures. So that's the set of the H bar as requested in the question. Okay, see, Ajit said in B we had to assume that H bar is normally distributed. So it was necessary to use the central limits theorem. Explain whether you agree with Ajit. Alright, so now let's look at the question. Okay, so from here, it's already mentioned that the H, the height, is normally distributed. So we do not need to apply the first shift, the central limits theorem, because it's already given normally distributed. Alright, so the question for this, the answer for this question is not agree. Okay, because the population of H is given as normally distributed with known variance. Okay, so if with known variance, basically we do not need to refer to the central limits theorem. Unless the variance or the distribution is not given, then the n is large, then only we apply the central limits theorem. Okay, so this is the explanation. Alright, now next question number 5. The random variable x has probability density function f given by fx equals to 1 over x squared, whereby the x is defined from a to b, or it will be 0 when the x is otherwise, okay, when x is other values. Now where a and b are positive constants. First part is given that expected x is ln 2. Show that b equals to 2a. Okay, now for the expected x, the definition is integrate at x fx dx, and then it will be defined for a to b. Okay, so from here I will just replace, so I will get integrate a to b x. My fx is this, so 1 over x squared dx, and the answer is given ln 2. So now before I integrate, I simplify the left hand side first. This is going to be integrate from a to b. X times 1 over x squared is 1 over x, which is ln 2. Okay, then now we have a formula. When you integrate fx, the denominator is fx, numerator is f prime x. This is going to be ln fx plus c. Okay, so now when I differentiate x, I will be getting 1. Therefore, it is in the same form of the ln formula. Therefore, I will just write ln x, then limits from a to b, it will be ln 2. Okay, then now replace the x by b first, which is our upper limit. Then you'll be getting ln b minus ln a, it will be ln 2. And now we need to show b equals to 2a. So I will just move the ln a to the other side because I want to get the b as the subject. Alright, so here is going to be ln b equals to ln 2 plus ln a. And now we have a formula, ln a plus ln b, it is same as ln of ab. Okay, when it is plus, then you combine both ln becomes 1 ln by multiplying the numbers. Therefore, here I'm getting ln 2 times a. And then left side is ln b. So since you have 1 ln on both sides, therefore the ln will be cancelled off. So at last, your b is 2a. So with this, we have shown the equation. Okay, now next part, show that a equals to 1 over 2. So now we know that integration from a to b fx dx is going to be 1. This is the total probabilities formula. Okay, so now I'm going to integrate 1 over x squared from a to b in order to get the a value. So it will be integrate a to b 1 over x squared dx, and it is 1. So to solve this integration, the x squared will be moved up. It becomes x to the power of negative 2. Okay, and now to do the integration, we use this formula, integrate x degree n, it will be x degree n plus 1 over n plus 1, then plus c. So you divide by the new degrees. So here I will get x to the power of negative 2 plus 1 is minus 1, then over minus 1, together with the limits a to b equals to 1. And now I simplify. So this negative 1 at the bottom here, or denominator, this minus 1 will be taken out. Then this power negative 1, I will move down the whole term. So that means this is going to be negative, then 1 over x. Because x to the power of negative 1, it becomes 1 over x. Limits from a to b. And now replace the a and b. Okay, so remember, your b just now we have found. B is 2a. That means now I can replace my b by 2a. Okay, so from here I will just write b equals to 2a. Then this is going to be negative 1 over x, a to a equals to 1. Then now replace. It will be negative 1 over 2a minus 1 over a. Okay, and now get the same denominator for the terms inside the square bracket. And I will be getting over 2a. So the first one, just copy. The second term to get over 2a. So here, basically, I times 2, then divide by 2. So therefore, you will be getting 2a in the numerator. So it's going to be negative 2a that equals to 1. Okay, so the negative move to the other side. Now, this negative and this 2a will be moved to the other side. That means it's basically negative 2a on the right side. So I will get 1 minus 2a equals to negative 2a. Okay. So, okay, I did a mistake here. This is this part. Here I times 2. This 2 times 1 is supposed to be just 2. Okay, mistake. So this is going to be right. So it means that if I simplify, sorry, I overlooked the question just now, the working just now. So from here, it will be negative. This 1 minus 2 is minus 1. Therefore, minus 1 over 2a. Okay, so minus minus is positive. Therefore, this 2a I move up. So 2a equals to 1. Hence, my a is going to be half. So that is the solution of this question. Okay, now C, find the median of x. So median is the property will be half. Alright, so from here I know that my a is half. So which means integrate from half to m fx dx, it will be 0.5 because now it will be from a to b. Okay, so now if I need to get the median, let's say this is the m, then I will just integrate from a to m and let it be 0.5 because this property is 0.5 if the m is median. So now I will just write integration of fx dx we have done just now, you see, which is here. Integration of fx dx is basically just this, right? So now I will change my limits. So I will write negative 1 over x. So this is going to be negative 1 over x, and then my limits, upper limit half, lower limit, sorry, upper limit is m, lower limit is half, then equals to 0.5. Then from here, I replace the x by m first. So it will be negative 1 over m minus 1 over half. So this 0.5 I can change to half as well. So then from here I will get 1 over m minus 1 divided by half is basically 2. Okay, then this minus I will move to the other side. Alright, therefore this is going to be negative half. And now we need to get the m. So this m I will say 1 over m equals to negative half plus 2. So which is 3 over 2. Then my m, right? So you can just swap. That means here also just switch. So it will be just 2 over 3. So that's the median. Okay, so here you can just write let m be the median. So now we have solved this question. Okay. Alright, so done for this part C. Now for question number 6. A factory makes loaves of bread in batches. One batch of loaves contains X kilograms of dried yeast and Y kilograms of flour, where X and Y have independent distributions. This will be the distributions. So now I will just write down first. X will be normally distributed 0.7, 0.02 squared, and then my Y is normally distributed with 100.0 and then 3.0 squared. Now, dried yeast, this is the X, cost $13.5, okay, $13.50 per kilogram, and flour cost 90 cents per kilogram. For making one batch of bread, the total of other costs is $55. The factory sells each batch of bread for $200. Okay, so I will write cost for X is 13.5. Cost for Y is 90 cents, 0.9. And then cost for others, right? Let's say T cost for others, it will be 55. And then selling price, all right, it will be 200. Selling price, it will be $200. Find the probability that the profit made on one randomly chosen batch of bread is greater than $40. So this is profit. All these are costs. Okay, so now from here I know that my cost. Okay, so let's say here this is the total cost. Total cost, it will be TC plus 13.5x, because this is per kilogram. This x is x kilograms. So total cost plus 13.5x plus 0.9y. So it depends on how y kilograms of the flour and 13.5 times x kilograms of the yeast, right? So from here I know that, let's say my total cost, I let it be T. So I just define this as T. Then now from here, my expected T, it will be expected TC plus 13.5 expected X plus 0.9 expected Y. Okay, so from here, it will be expected TC. TC is fixed 55. Then plus 13.5 expected X is the mean. This is the expected X. And 100 is the expected Y. Then from here, I will be getting times 0.7 plus 0.9 times 100. Therefore, you will be getting 154.55. That is the expected cost. Now I need to calculate what is my variance of the cost. So variance of the cost, it will be variance of these three components. So I will write variance of TC plus 13.5x plus 0.9y. Okay, then from here, variance of TC, TC is the constant, right? So according to the laws of variance, when you have constant, let's say variance of ax plus b, so the b is constant, you will be getting a squared variance x, so the b will be ignored. Therefore from here I will be getting just 13.5 squared variance x, right? So it will be 13.5 squared variance x plus 0.9 squared variance y. Okay, so the variance x and y, you can get it from the distribution. This will be variance x, and the 3.0 squared will be the variance y. So then when I calculate the value, okay, or when I replace the value, I should get 13.5 squared times 0.02 squared plus 0.9 squared times 3.0 squared. So then from here you will be getting 7.3629. Okay, so I have found the distribution of the cost. It will be 154.55 and 7.3629. Okay, so now I need to find what is the probability of getting the profit with which is greater than $40. So we know that profit is going to be selling price minus total cost. Okay, so now your profit means this is going to be greater than, okay, profit is greater than $40, right? That means selling price is $200 minus the total cost. Right, total cost we do not know. But then it will be greater than $40. Right, because it's given in the question. The profit is greater than $40. So we use this equation or this concept to get the equation of profit. Okay, so now I need to get the t because I already found the distribution of t. So this t, you just move to the left side, to the right side to get positive, and then this 40 you move to the left side, which means, okay, basically my t move to the left side, it will be like this. So 200 minus 40. So, or when I read the t from the right side, it will be t less than 160. So now we need to calculate pt less than 160. Okay, instead of calculating the probability of profits more than $40, I'm counting probability that the cost is less than 160. Alright, so now standardize it because it is normally distributed. So it will be probability of z less than 160 minus 154.55 over variance, over standard deviation. So square root of the variance, so 3629. Alright, so then from here you will be getting pz less than 2.045. Then now when you just sketch a graph, here is 2.045 and this is less than, therefore the region towards left side. Then from here just direct read the table, the normal table, you will be getting 0.9795, and now I round up to 3 significant figures. Since the last digit is 5 and above is 5, therefore we round up. So when you round up, this value becomes 79 becomes 80, so it will be 0.980. So that's the probability of this question. Okay, now next question, number 7. A random variable x has the distribution Poisson distributed with lambda or mu equals to 2.4. Now calculate this probability. So that means now px inclusive 2 but less than 4. Alright, therefore this is same as px equals to 2 or px equals to 3. And now if you still remember just now, when this is your Poisson distribution, right, the probability is basically e minus mu to the power of x over x factorial. So then from here, I will be getting e to the power of negative 2.4. I will factorize this term because this is constant. Then it will be 2.4 squared over 2 factorial. Plus 2.4 cubed over 3 factorial. Okay, so when you calculate this value, it's going to be 0.47028. And now when I round up to 3 significant figures, that is going to be 0.470. So that's the solution for 7a. Okay, now b, 2 independent values of x are chosen. Find the probability that both of these values are greater than 1. Okay, probability. So now, let's say your x1 is Poisson distributed with mean, with lambda or mu 2.4, and same goes to the x2 because they are independent variables or independent values. So you are getting this. Now, since both are greater than 1, both values means x, so now I'm counting px1 greater than 1 because of both values, so I have to times with the next value is also greater than 1. Okay, so I can just write times. Alright, so from here, if you need to get both probabilities greater than 1, so it will be 1 minus px equals to 0 plus px equals to 1. So you minus these two values. Alright, it will be the same for both. So 1 minus px equals to 0 plus px equals to 1. So you minus these two values. So, on other words, I will say 1 minus, since both also same probability, it will be px equals to 0 plus px equals to 1. So you minus both of these. After that, you square it. It will be the same. Right? So then you will be getting 1 minus e negative 2.4. And then put another bracket. So 1 plus, because when the degree, okay, supposedly is okay, I show step by step working. So it's supposed to be 2.4 degree 0 over 0 factorial. Then plus 2.4 degree 1 over 1 factorial. Okay, then from here, you will be getting 1 minus e negative 2.4 bracket 1 plus 2.4. Then all of this, you square it. Then at last, you will be getting 0.47825. And now when I round up to 3 significant figures, you will be getting 0.478. So that's the solution of this question. Okay, now it's given that px equals to r is less than px equals to r plus 1. So find the sets of possible values of r. So now, again, the formula is x is PO 2.4. So your px equals to r is going to be e minus 2.4, 2.4 to the power of r over r factorial. Okay, this is our formula. So now I'm going to replace it. Px equals to r less than px equals to r plus 1. That means I'm getting e negative 2.4, then 2.4 to the power of r over r factorial is less than e negative 2.4, then 2.4 to the power of r plus 1 over r plus 1 factorial. Okay, and now we need to get the r, therefore the e will be cancelled off from both sides. And now, okay, we have 2.4 power r and 2.4 r plus 1. So from here, I will get 2.4 to the power of r over r factorial less than. This 2.4 to the power of r plus 1 is basically 2.4 to the power of r times 2.4 to the power of 1. Okay, over. Now the r plus 1 factorial, just for your information, if it is 3 factorial, I will get 3 times 2 times 1. Then if it is 2 factorial, it will be 2 times 1. So from here, I will say that this 2 times 1 is basically 2 factorial. So on other words, 3 factorial is 3 times 2 factorial. And now from here, if I let my r be 2, okay, because here I need to show 2 r and r plus 1. Therefore, my r plus 1 is going to be 3. So based on this conclusion, I will be getting r plus 1 factorial, which is r plus 1 times r factorial. Okay, which is tally with this. So then from here, I will write r plus 1 factorial is basically r plus 1 times r factorial. And then now I can cancel terms. So 2.4 to the power of r cancel off. R factorial will be cancelled off. And then to get the r, right, this r plus 1 will be moved up. Okay, therefore, I will be getting r plus 1 is less than 2.4. So then your r is less than this 1 move to the other side, I will be getting 1.4. So when r less than 1.4, remember, your r will be the x values. So less than 1.4 means that your r will be 0 or 1, because the x is Poisson distributed, it must be discrete. Okay, that means you cannot accept integer, cannot accept the interval. It must be discrete. Therefore, my r will be just 0 and 1. So you can accept these two values. Okay, now next part, hence. Hence means use the previous answer. Find the value of r for which the probability of x equals to r is greatest. So now from here, from the previous part, we know that px equals to r less than px equals to r plus 1. Okay, so from first part, px equals to r is less than px equals to r plus 1. And we have found that r equals to 0 and 1, which means when I replace the r by 0, I will be getting px equals to 0 less than px equals to 0 plus 1 is 1. And when my r is 1, I will be getting px equals to 1 is less than px equals to 2. Okay, so from here, when you analyze this, px equals to 0 less than px equals to 1. That means px equals to 1 is greater than px equals to 0. But then px is equals to 1 is less than px equals to 2. That means this probability will be the greatest. Okay, so then from here, px equals to 2 is the greatest. Therefore, okay, the r value is 2. Okay, so this is how we analyze this question from the previous part solution. Now, we have come to the end of the video. Thanks for watching. Okay, please subscribe to the channel and like this video if you enjoy watching my video. And also stay tuned for more upcoming videos. Thank you. Bye.